The A part was a very long one. The B part said that from the graph, that means we should plot the graph of the two equations. Now from the graph, okay, even from the onset, they said we should draw the graph of. So we are not solving the part B of the equation, where he said that we should, from the graph, find the roots of the equations and compare it with our answer in the equation A. Yes. The equations we have there are two. One is quadratic, which is x squared minus 2x minus 5 is equal to 0. The second one is linear. 2x minus 3 is equal to 0. Now we are going to construct two tables of values. One for the quadratic equation, the other one for the linear equation. So let's first of all construct the table of values for the quadratic. Our quadratic equation is x squared minus 2x minus 5 is 0. Remember, this 0 will be changed to y before it will be applicable. And I want us, the examiner was silent in the range of values for which we take the table of values. So I would like us to adopt, in this case you adopt by yourself. Let's adopt the range of values from minus 3 to plus 5. So we now start from when x is equal to minus 3. Begin to substitute minus 3 for x in the equation. We are now going to have minus 3 squared minus 2 times minus 3 minus 5 will now be equal to y. Minus 3 times minus 3 will give you plus 9. Minus 2 times minus 3 will give you plus 6. Bring down minus 5 is equal to y. 15 minus 5 will give you 10. That means our y here is 10. The next will be when x is minus 2. The next number in ascending order after minus 3 is minus 2. Some students used to make the mistake. After minus 3, they will go to minus 4. Minus 4 is less than minus 3. When you are going, when they say from minus 3 to minus 5, that means from the least to the greatest. When you are ascending, the next number after minus 3 should be minus 2. So begin to substitute the value minus 2 for x. So we have minus 2 squared, replacing x squared, minus 2 times minus 2, replacing this, then minus 5 is equal to y. Here we have 4, minus 2 times minus 2 is plus 4, minus 2 times minus 2 is also plus 4, then minus 5 is equal to y. 4 plus 4 is 8. 8 minus 5 will give you 3. So we have that y here is 3. The next will be when x is after minus 2, you have minus 1. Begin to substitute the value of x, which is minus 1 now, in the equation. We are going to have minus 1 squared, replacing x squared, minus 2 times minus 1, replacing minus 2x, then minus 5 is equal to y. Minus 1 times minus 1 will give you 1. Minus 2 times minus 1 will give you plus 2. Bring down minus 5. That is the value of y. 1 plus 2 is 3. 3 minus 5 will give you minus 2. So the value of y here is minus 2. The next is when x is 0. The next number after minus 1 is 0. Begin to substitute the value 0 for x in the equation. X squared will now be 0 squared minus 2 times 0 minus 2x minus 5 is equal to y. 0 squared is 0. Minus 2 times 0 is 0. That means in this case minus 5 is the value of y. The next is when x is 1. When x is 1, x squared will become 1 squared minus 2 times 1 minus 2x. Then minus 5 is equal to y. 1 squared remains 1. Minus 2 times 1 will give you minus 2. Then minus 5 is equal to y. 1 minus 2 minus 5 will give you minus 7. If you subtract 1 from it, you will have minus 6. So the value of y here is minus 6. Let's squeeze 1 this place. The next is when x is 2. That means x squared will be 2 squared. X squared will become 2 squared. Minus 2 times 2 minus 5 is equal to y. We have 4 minus 5 is equal to y. 4 minus 4 is 0. That means minus 5 is the value of y at this level. The next is when x is 3. You find out that from the equation we have 3 squared replacing x squared minus 2 times 3 replacing minus 2x, then minus 5 will give us y. 3 squared is 9. Minus 2 times 3 will give you minus 6. Then minus 5 is equal to y. 9 minus 6 will give you 3. 3 minus 5 will give you minus 2. That means at this level, the value of y is 2. The next is when x is 4. Begin to substitute the value of x to be 4 in the equation. Instead of x squared, we have 4 squared. Instead of minus 2x, we have minus 2 times 4. Then bring down minus 5 is equal to y. 4 squared is 16. Minus 2 times 4 will give you minus 8. Then minus 5 is equal to y. 16 minus 8 is 8. Then 8 minus 5 will give you plus 3. The value of y at this level is plus 3. The last but not the least is when x is 5, which is the greatest number on the range of values that we have taken. When x is 5, x squared will be 5 squared. Minus 2x will become minus 2 times 5. Then minus 5 is equal to the value of y. 5 squared is 25. Minus 2 times 5 will give you minus 10. Then minus 5 is the value of y. 25 minus 10 will give you 15. 15 minus 5 will give you 10. So we have that at this level, the value of y is 10. So these are the values we have for x and its corresponding values for y. So we are going to now use it to construct the table of value for the quadratic equation. When I clean off this, you are going to see the table of value mounted here, where you are going to have the value for x minus 3, y 10, x minus 2, y 3, x minus 1, y minus 2, x 0, y minus 5, x 1, y minus 6, x 2, y minus 5, x 3, y minus 2, x 4, y 3, and x5, y 10. That is what we are going to see in the table of values. The linear equation reads 2x minus 3 is equal to y. We start by saying when x is equal to minus 3. Remember, we are asked for range of values of x from minus 3 to 5. So let's start from minus 3. Wherever you see x in the equation, replace it with minus 3. So we're going to have 2 times minus 3 minus 3 is equal to y. 2 times minus 3 will give you minus 6. Minus 6 minus 3 is the value of y. Minus 3 minus 6 is minus 9. That means the value of y is minus 9. The next is when x is minus 2. Use minus 2 to replace x in the equation. We are going to have 2 times minus 2 then minus 3 is equal to the value of y. 2 times minus 2 is minus 4. Then minus 3 is equal to y. Minus 4 minus 3 will give you minus 7. And that is the value of y in this part. The next is when x is minus 1. Use minus 1 to replace x. 2x becomes 2 times minus 1. Then bring down minus 3 is equal to the value of y. 2 times minus 1 is minus 2. Then minus 3, that's the value of y. Minus 2 minus 3 is minus 5. That means that the value of y is minus 5. The next is when x is 0. After minus 1, the next number in ascending order is 0. 2x becomes 2 times 0. Then minus 3 is the value of y. 2 times 0 is 0. Minus 3 is the value of y. That means minus 3 is y. The next is when x is 1. The equation becomes, instead of 2x, you have 2 times 1 minus 3 is equal to y. 2 times 1 is 2. Then minus 3 is y. 2 minus 3 is minus 1. And that is the value of x at this level. The next we're going to take is when x is 2. 2x becomes 2 times 2. Then minus 3 is equal to y. 2 times 2 is 4. Then we have 4 minus 3 is the value of y. 4 minus 3 will give you 1. That means the value of y at this level is 1. The next is when x is equal to, after 2 you have 3. 2x becomes 2 times x, then minus 3 is y. 2 times 3 is 6. We have 6 minus 3 is the value of y. That means 3 is the value of y at this point. The next is when x is 4. 2x becomes 2 times 4 minus 3 is the value of y. 2 times 4 is 8 minus 3 is y. That means 5, which is 8 minus 3 is the value of y here. The last but not the least, when x is 5. 2x becomes 2 times 5. Then minus 3 is equal to y. 2 times 5 is 10. Minus 3 is the value of y. That means 7, which is the value of 10 minus 3. Becomes the value of y at that level. You can see, in this case now, we have derived the corresponding values of y for the values of x ranging from minus 3 to 5. Now we are going to clean up this just the way we did on the quadratic table of value finding. After cleaning up this, you are now going to see the quadratic table of value and the linear table of value, which we are going to use to plot the graph. Now this is the table of values now that we have labeled in constructing. When x, for the quadratic, when x is minus 3, y is 10. When x is minus 2, y is 3. When x is minus 1, y is 2. When x is 4, y is 3. And when x is 5, y is 10. For the linear, when x is minus 3, y is minus 9. When x is minus 2, y is minus 7. When x is minus 1, y is minus 5. When x is 4, y is 5. And when x is 5, y is 7. These are the table of values we are now going to use in plotting the graph. When next you will see this whiteboard, you are going to see our graph paper pasted here, because we are not going to plot on a white board. We don't plot on assumptions. We are going to plot right inside a sheet of our graph paper. Now this is the graph book. On the exercise book side of the graph, you can see the table of value for x squared minus 2x minus 5 is equal to 0, the quadratic. Below it is that of the linear. 2x minus 3 is equal to 0. Then down is the question from where we were able to solve algebraically question number A before we now come to solve question number B, as you are seeing on the screen now, written on the exercise book side of our graph paper. That's the question. Now on the other side is the graph paper. You can see it on the screen. On top of it, you can see it reads graph of x squared minus 2x minus 5 is equal to 0 and 2x minus 3 is equal to 0. That is the simultaneous linear and quadratic equations. On this other side, you could read using scale of 2 cm to 1 unit on x-axis, that is on the horizontal axis, and 2 cm to 2 units on y-axis, that is on the y-axis. Now the first thing I want to do now is based on the values we have on our table of values. You could see that the highest value of x is 5, while the smallest value of x, or the minimum value of x, is -3. So when you are calibrating on your graph paper, each of these squares, big squares you are seeing on the graph paper, measures 2 cm. So you are going to give enough gap to be able to contain both the negative and the positive side of the values you are to plot therein, as you are going to extract them from the table of values. When next you see this graph paper, I must have calibrated it. Then the next thing is we'll start plotting the values we have on our table of values. You can see now that I have calibrated the graph book. I calibrated it based on the scale. The scale says that we should use 2 cm to 1 unit on x-axis. This is the x-axis. You can see it written x-axis. The horizontal axis is the x-axis. And based on the scale, 2 cm to 1 unit, that was why you saw in between every 2 cm you have 1 unit. From here to here is 2 cm, and the calibration is 1. From here to here is another 2 cm. You have 2, 3, 4 in that progression until the end. That is what it means by 2 cm represent 1 unit. On the negative side, from here to here, you have -1, -2, -3. That's exactly what is meant by saying 2 cm to 1 unit, as you have it on the scale, 2 cm to 1 unit. Then on the y-axis, they say 2 cm to 2 units on y-axis. The y-axis is the vertical axis. You can see it, y-axis. This vertical axis is the y-axis. And the scale says 2 cm to 2 units. And that was why you saw on the calibration, from 0 to the first 2 cm you have 2. From 2 to the next 2 cm you have 4. It increases by 2. And that is what is meant by 2 cm to 2 units. Then down the negative side also, from here to here is 2 cm. You can see you have -2, -4, -6, and it goes that way. The next thing we do now is we start plotting the values we have on our table of values. You can see, first of all, that of the quadratic. When x is -3, y is 10. So go to the calibrated graph paper. All these values are values of x. It says the first, when x is -3, y is 10. So go to where x is -3. X is -3 here. Then find the value of 10. Look at where y is 10. And look at where x is -3. So the point of intersection of the line of -3 and +10, put your dot. After calibrated the first value, go back to the table of values. When x is -2, y is 3. So look for x is -2. Look at where x is -2 and y is 3. From here to here is 2. From here to here is 4. That means 3 should be halfway 2 and 4. From here to here you have 10 small squares. Let's count it. From here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small squares. If from here to here is 2 units, that means the halfway is 1 unit, and if you add that 1 unit to 2, you get 3, which you are looking for. So 5 small squares is what we will count from here. 1, 2, 3, 4, 5. This is where 5 small squared is. Now remember, they said when x is minus 2, y is 3. So x is minus 2 here, and y is plus 3. This is the line of minus 2 for x, and this is 2 for y. Then from here, if you count 5 small squares, that is exactly where you plot. 1, 2, 3, 4, 5. So this is where you put your point. So we have plotted the second value. Then the third, go to the table of values. When x is minus 1, y is minus 2. When x is minus 1, y is minus 2. So this is the correct place. The next place or the next values are when x is 0, y is minus 5. X is 0 here, and also y is 0 here. But the values there is when x is 0, y is minus 5. So x is 0 here, and y is minus 5. This is minus 4, and this is minus 6. In between minus 4 and minus 6 is 5. Just count 5 small squares. 1, 2, 3, 4, 5. So this is where you have 5. In between minus 4 and minus 6, you have minus 5 here. So we are going to plot here. 1, 2, 3, 4, 5. We're correct. Let's go to the next value. It says when x is plus 1, y is minus 6. When x is plus 1, y is minus 6. So this is the place you plot. Okay. The next is when x is 2, y is minus 5. When x is 2, y is minus 5. Look at the place where x is y is minus 5. So if you trace it to where you have 2, so this is the place you are going to plot. One, 2, 3, 4, 5. You are correct. When x is 2, y is minus 5. When x, the next is when x is 3, y is minus 2. So come, this is where x is 3, y is minus 2. Look at where y is minus 2. So the point of intersection of the two lines is where you plot, and that is exactly this place. The next is when x is 4, y is 3, and plus 3. So when x is 4, y is 3. This is where y is 2, and where y is 4. So in between the lines, come to where x is 4. This is 2. 1, 2, 3, 4, 5. So this is where you are going to plot, where y is 3 and x is 4. You are going to plot here. The last values are when x is 5, y is 10. This is where x is 5, and this is where y is 10. So the line where both of them met is where you are going to plot. 5 and 10. So you plot disgrace. You can see that we have finished plotting the quadratic curve. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it corresponds with 1, 2, 3, 4, 5, 6, 7, 8, 9 values of x and y. Now in this case we are going to use a broomstick. I repeat, a broomstick to link these plotted points to form the quadratic curve. So we are going to, now this is the broomstick I'm going to use in joining the points. What you do is, each time you want to join, try to join at least 3 points at a time. That is what I will give you the most perfect and correct curve. Join 3, just as you have here. This is the first point, this is the second, and this is the third. So try to join 1, 2, 3 at a time. And that's exactly what I'm going to do now. I'm going to join the 3 at the same time now. Just watch. The 3 points I want to join now are 1, 2, and 3. So just put your broomstick. You must do it very carefully. Put your broomstick. Yes, they are connected now. Now use your pencil and join. You can see I've joined the 3 now. Then the next now is the next 3 points. The next 3 points is where you stopped. This is the next one, that is the second one, and this is the third. So I'm going to join 1, 2, 3 now. You can see that I have placed the broom to connect 1, 2, 3. So I'm going to join now. This broomstick, maybe before your exam day, you can soak it inside water. You can soak like 1 or 2 or 3 broomsticks. It can be 5. Soak it inside water overnight. When it is soaked with water, you can bend it. It will not break when you are trying to join your points. The next one now is 1, 2, 3. We try to connect 1, 2, 3 now. You can see I have connected the 3. So it's left for me to join now. You can see I have joined. The next is the last 3 points now. The last 3 points. 1, 2, and 3. So we're going to join that now. I've connected it, so let me join. So it's a very long one. Okay. So I've joined it. We just finished plotting the quadratic curve. Now let's plot the linear line from the second table of value of 2x minus 3 is equal to 0. That is this one. So let's start. The first value is when x is minus 3, y is minus 9. I intentionally calibrated this in this way. If you will find out that the graph paper did not contain where y is minus 9. It stopped at minus 8. And here we have that y is minus 9 when x is minus 3. So if you want to plot minus 3 against minus 9, you cannot get minus 9. Why did I say I intentionally did it? Some students, when they get to this level, after they have wasted all this time, they will cancel this and start afresh. As long as it is linear equation that you are plotting, even if you plot only 3 points, maybe you start from minus 2 and minus 7, and now plot the next one 1 and minus 1, then the last one 5 and 7, you still get your correct line. So in this case, since we did not have minus 9 accommodated in our graph paper, we are going to jump where x is minus 3 and y is minus 9 and start from where x is minus 2 and y is minus 7. That's exactly what we're going to do now. When x is minus 2, y is minus 7. This is minus 6. So the halfway, 1, 2, 3, 4, 5, 5. So this place now is where x is minus 7 and y is minus 2. So we're going to plot this place. So put a point here. Okay. Then the next is when x is minus 1, y is minus 5. X minus 1, y minus 5. Minus 5 should be halfway minus 4 and minus 6. So we have 1, 2, 3, 4, 5. So this place we are going to plot. The next is when x is 0, y is minus 3. X is 0 here and y will be minus 3 in between minus 2 and minus 4. So we have 1, 2, 3, 4, 5 small squares. So we're going to plot here. The next is when x is 1, y is minus 1. When x is 1, y is minus 1. Minus 1 is in between 0 and minus 2. So we are going to have 1, 2, 3, 4, 5. So we're going to plot here. The next is when x is 2, y is plus 1. When x is plus 2, y is plus 1. Plus 1 is in between 0 and plus 2, which is 1, 2, 3, 4, 5 small squares. So you plot the next point here. The next is when x is 3, y is 3. When x is 3, y is 3. 3 is in between 2 and 4. So we are going to have 1, 2, 3, 4, 5 small squares. So this is the place we are going to plot. The next is when x is 4, y is 5. When x is 4, y is 5. 5 is between 4 and 6. So we're going to have 1, 2, 3, 4, 5. This is the place to plot. The last, when x is 5, y is 7. We're going to see when x is 5, y is 7. 7 is in between 6 and 8. So we're going to have 1, 2, 3, 4, 5. So we're going to plot this place. So you can see the points we plotted. The first one is here, second one is here, third, fourth, fifth, sixth, seventh, eighth. Corresponding to, remember we did not plot the first values. 1, 2, 3, 4, 5, 6, 7, 8. Now the next thing you do is you use your ruler and join. In this case, when you have plotting the graph or the points of a linear equation, you use a ruler to join. Whereas you use a broomstick to join the quadratic. So you're going to join this line. Is going to give you a perfect straight line with a ruler. You can see the straight line and how it cuts the curve at 2 points, this place and this place. Now the next thing we do is we go to the questions now and answer the questions from the graph we plotted.